This is question 8 from the Spring 2015 AMATYC Student Math League contest. Question says, if x minus 1 squared is a factor of p of x equals 2x to the fifth minus 4x to the fourth plus x cubed plus ax squared plus bx plus c, we want to find a minus c. This one, there's sort of a straightforward algebra way to do this. There's also another way that uses some calculus, which you technically don't need for this contest, but actually makes the problem a little bit simpler. I'm going to do the straightforward way first. Here, first of all, x minus 1 squared, that's x squared minus 2x plus 1. And if this is a factor of this big polynomial, that means when I do long division, I should get 0 as my remainder. So let's just do the long division. So I get 2x to the fifth minus 4x to the fourth plus x cubed plus ax squared plus bx plus c. I divide that by x squared minus 2x plus 1. I guess you could divide by x minus 1 twice, but I can do that in one shot this way. And I'm going to think x squared times what gives me 2x to the fifth? Well, I'll need a 2. Then I have to have an x to the third. I do 2x to the third times x squared is 2x to the fifth. 2x to the third minus 2x to the fourth is minus 4x to the fourth. 2x to the third plus 1 is 2x to the third. And then I'm going to subtract. Get a 0. That's the point of choosing 2x to the third. Get a 0 here. That's lucky. X cubed minus 2x cubed. See, that's a negative x cubed. Plus, let's see, ax squared plus bx plus c. Okay, now I'm going to think x squared times what gives me negative x cubed. That's going to be a minus x. Note we missed out on our x squared term. That's because this 4x to the fourth canceled out. X times x squared, sorry, negative x times x squared, that's negative x cubed. Negative x times negative 2x is positive 2x squared. Negative x times 1 is negative x. And then again, I subtract, the negative x cubes cancel. I'm going to get a minus 2 times x squared plus b minus negative 1 is b plus 1x plus c. And I can keep doing my division. X squared, I need to multiply by a minus 2 to give me a minus 2x squared. So I'm going to do that. I get a minus 2x squared. And then I'm going to get minus 2 times a minus 2x. And then I'm going to get plus a minus 2 as sort of my constant term. So maybe create some more space here. Well, no, I guess that's all we've got. So what we're going to do now, so when we do our subtractions, these cancel. When I subtract here, I'm going to get b plus 1 plus 2 times a minus 2. All of that times x. And then we get plus c minus a minus 2. That's my constant. Now this is my remainder. And for x minus 1 squared to be a factor here, what I need is for this remainder to be 0. That means that this coefficient of x has to be 0, and this sort of constant term coefficient also has to be 0. Now I'm going to focus on the constant term because it'll give us what we need here. So we know from this that c minus a minus 2 is 0. Let's distribute that negative. C minus a plus 2 is 0. And now I can subtract the c and add the a to both sides. And I'm left with 2 equals, well, this is a minus c. And over the a minus c equals 2, but that's what we were looking for. So our answer here is a, that's 2. And this, isn't so bad. But there's another way that we can do this here if we want to use calculus. Let's maybe do this in green. What I'm going to do, let's go to a new page. So it's 2x to the fifth minus 4x to the fourth. And let's see, the rest of that was plus x cubed plus ax squared plus bx plus c. So this was our, what do I call this? Was it f of x? P of x. Polynomial is p of x. And we know x minus 1 squared is a factor. Now here's where we use our calculus factor. So if x minus 1 is a factor of p of x, no calculus yet, what that means really is that p of 1 equals 0. Here. So what that means, I plug in 1 for x, I get 2 times 1 to the fifth is 1, minus 4, plus 1, plus a, I mean basically the x's go away, plus b plus c equals 0. Let's see, this is 3 minus 4, negative 1. Can move to the other side as 1. I get a plus b plus c equals 1. So that's one equation. That's just because x minus 1 is a factor of p of x, because x minus 1 squared is. Now when you have a repeated root like that, it turns out that x minus 1 is a factor not just of p of x, but of the first derivative p prime of x. So here's where you have to know the calculus. You know, sort of to back this up, you probably need a little bit of calculus. But you also need to know the calculus to take the derivative. For a polynomial, that's pretty easy. What I do is I take this 5 times 2. So basically I have 2, let's just write it this way. I have 2 times x to the 5th. I take this exponent, bring it down in front, that's 5. And then I do x, and I decrease my exponent by 1. So the 5 becomes a 4, but I sort of bring a 5 out. Next one, I keep the minus 4. The 4 comes down. And I have x to the 4 minus 1, that's 3. Next one, the 3 comes down as a 3. 3 minus 1, that's 2. Next one, the 2 comes out, well, I have a. I have a 2 out in front, and I get x to the first, that's just x. And bx, I have an x to the 1, so that's plus b, really times 1. But then x to the 0 is just 1, so that stays. And it turns out that c, I guess, is c times x to the 0. Bring the 0 down, you're multiplying by 0, that goes away. Derivative constant is 0. So you get this p prime of x here. X minus 1 is a factor, and what that means is p prime of 1 has to be 0. So if you put that together, you put in a 1, you get 2 times 5, that's 10. 4 times 4, this is 16, and then the 1 cubed is just 1, plus 3. Then we're going to get 2a plus b, that's 0. And what you get from this, 10 plus 3 is 13, minus 6 is 13 minus 16 is negative 3. You can bring that to the other side. We get 2a plus b equals 3. So we get these two equations, which we can get to without having to do all the long division. And then if you take the 2a plus b, let me switch to another color. You take the 2a plus b equals 3, and you subtract a plus b plus c from the left, and you subtract 1, that is, you subtract sides of this equation from both sides here. What you get is, let's see, 2a minus a, that leaves me with a. B minus b cancels. I get a minus c. Hey, that's what we were looking for. 3 minus 1 is 2. So you can get your 2 this way as well using a bit of calculus. Kind of a nice little trick to have, but you've got to know this fact about multiple roots being sort of means the derivative is 0 as well. And you need to know how to take derivatives of polynomials, which is something a lot of people wouldn't have seen, but it's not that bad for polynomials.